we're already ready. We're waiting for you. So let's start. Per was actually saying some words. So if you Per, you can continue, I believe.
Yeah, Scott and I have started this little venture. We believe we have something that's viable in the future in making quantum happening. As we've been speaking, what we want to focus on is basically how can we help you make quantum a factor of trading quicker in a shorter distance of time with more profit. And then we all understand how, most of us understand how that works. It's all a spread. It's called spread betting, right? I believe you win, you believe I lose, and then we have a middle in between. But we think with the API that we've developed, and I won't take any of the thunder away from you, Scott, but
obviously I've been asked by Per to just sort of come in and just put some clarity on what we might be able to bring in. So I'm going to try and keep it simple. I'm going to try and keep to what I think are the uses. So you guys are obviously talking about quantum. I'm probably going to make you all sad and say that, as you're aware now, there isn't really much commercial application coming out of quantum in terms of quantum hardware that doesn't cost billions of dollars and can only do mathematical equations with 3 numbers in. Then it's not very powerful. Future power is one thing. What does come from quantum, what I'm trying to say is that what quantum computing can do and what people in the press think it can do are 2 separate things. And I would put myself out there and say that the applications of quantum computing that you can use in your industry, you can count on less than 5 fingers, because most of the power of quantum computing is in very, very, very specific application cases. And I think most of them are not applicable to finance, other than crypto, possibly with the doom of breaking SHA-256 hashes, which is irrelevant in this conversation. What we can do with quantum now, and the most useful part of quantum computing for me, is quantum machine learning, because quantum machine learning helps us power very efficient and fast search algorithms and neural networks. And we can do that now on simulation in a way that's way faster than you can do with any kind of classical technology. So if I'm going to come into this project and this team to advise, I'm going to say 90% of quantum computing is of no interest to you. The more universally applicable parts of quantum computing that you're going to be able to lever are machine learning and search, particularly things like Grover's search and parallel search capabilities to drive the processes that you need. It's not a magic box, quantum computing, where you go, it's got the answer to everything in the universe and you get the answer out. So I'm going to try and set your expectations at that. What we've built is quantum-centric machine learning that's got an eye on future processor technology, and we're also developing our own processor technology to take advantage of the machine learning that we've got. So we have very powerful machine learning that can search billions and billions of combinations of patterns in a second, so fast as to be almost unbelievable. And we can do that on simulations that we've got now in split seconds. And hopefully a year or so down the line, when we bring out I think machine learning is the opportunity to lever any kind of quantum acceleration into what you're doing now in the near term, within the next year or two. So what we're doing at Teridion at the moment is very, very much around search, storage, and pattern recognition for applications such as AML, KYC, secure authentication, and also parallel search. And I think the last one, Joseph, if you want to make a note of it, is things like very broad input risk assessment in real time. So those are the types of applications that I think we can help you with in ways that you didn't think were possible. So if you could perhaps just finish at that there. Yeah. So I think that's what we can help you with. I think what we need to know is where do you think you need acceleration in what parts of the business, or is there it's possible that you've got problems that you don't think can be solved that you're just living with. That this sort of technology could solve problems that you don't even know you've got. But I think, are there any problems at the moment that you think this would be helpful? That the ability, that our abilities, that's what you're looking to, So I'm just going to demonstrate this because it's easy for non-technical people to understand also as well. But if there's any mathematicians or information theory specialists on the call, feel free to ask a question. So in a demonstration earlier this year, we set a task for this quantum machine learning that's impossible to solve with a classical machine. It was using a quantum simulation. So this is an intractable problem, which is what quantum computers are famously supposed to be able to solve. It's problems that can't be solved by any classical method in any time frame that makes sense to anybody. So what we've done here is we have a photograph on the left of Barack Obama. Hello, Mr. President. We take this photograph and we train a neural network, a quantum neural network, with this photograph. That's one step, train the photograph to the neural network. Then we delete the photograph, get rid of the Barack Obama, and we take the photograph and cut it into 10,000 squares here, so you can see 10,000 tiles is this picture here. So then we remove the neural network and leave one quantum memory pattern, very small, only 128 bits of information. So the image goes to the neural network and becomes 128 bits of information plus the neural network. Then we take away the neural network, discard it, delete. Then we ask the quantum computer to recreate this image of Barack Obama from the random picture of the 10,000 jigsaw pieces on the right. This puzzle represents a very difficult problem. There are 10,000. The question is, how many ways can this puzzle be reassembled? And this is, so it becomes a factorial problem, n factorial problem. And there are 10,000 pieces, so 10,000, and this little figure here means that it's a factorial problem from mathematics. So there's 10,000 times 9999 times this, and on and on and on and on. So actually a 10,000 factorial puzzle, there is almost not enough time to make the number of how many ways you can rearrange the puzzle. So I calculate this for 1,000 tiles, and the number of ways that the puzzle can be rearranged is this number here that you see here. So it's a very, very big number already, but actually for 10,000 pieces, is more like 500 pages of this number. That's how many ways that it takes to do this puzzle. That, although the demonstration is, well, we're not trying to solve jigsaws, what we're doing is we're searching information and mapping information, you know, with machine learning, creating patterns, searching for patterns and matching patterns to outcomes. So that's what machine learning is. And so this demonstrates that the elastic sort of search capability of a machine learning system powered by this technology can do things that you can't do with a normal technology. So that's it. There's no, there's nothing to it. So we harness this and use it for things like authentication. So if it can recognize Barack Obama in that mess of puzzle, it can recognize other things in other data. You know, replace Barack Obama with some other information that you can imagine, and then we can put it back together, or we can search it, find patterns, that sort of thing. So yeah, okay.
Thank you so much.
So I'm going to pass it back to you, and then because I'm looking at 1738. So yeah, okay.
I don't know. I think I will be able to, you know, to follow up any questions that the crowd might have, and I would like to thank you so much. Thank you so much for coming and sharing this information, Scott. Thank you. Okay. And I'm really grateful. All these grateful people out there. So,
but yeah, you're looking at search space of billions of search spaces a second. You know, it's almost beyond belief. So, all right. No problem. Yeah, so, I think Per is still on, but I don't know if he's got anything to say. So Per, have you got anything to add here?
Yeah, but I just want to reiterate one of the tests that we did on the other call the other day was basically going from Manchester to Dallas to Manchester, doing a full authentication cycle,
yeah,
for logging in and stuff like that in 0.125 seconds?
Yeah, thereabouts. Yeah, so yeah, a tenth of a second at the moment. We can do a real-time train and read write back to and from over API. So, you know, and we can go quicker than that, but it's, you know, it's about cost. You know,
we can do many things. We can do things quicker, better, more secure. But we need to put a stake in the ground and basically do a matrix of how we want this technology to help you. So we'll work with the technology team to basically put the stake in the ground. What is more important for us? I happen to believe security is very important, and I know Scott does as well. But and also, some of the exchanges that we're going to be working with, like Bitfinex and Binance, are notoriously slow on the trading side, and until we connect to them on a trinary, and listen to what I'm saying now. Binary is 1 and 0. Crypto is trinary, so you have 1 and 0 plus between. Until we connect on that level with them, our speed is only going to be 5-fold. When we connect to them on a different, Scott, I don't know if you can add to the.
Okay, let me translate that bit.
So trinary and binary speed of computation, that is.
Well, it's relative to how much data we are processing. So when I was sharing the screen before, I showed the graph, but it's disappeared now because they took the sharing away, so I can't do it. But you know, we're looking at multi-terabits a second in search space for certain types of stuff. So it depends on the application. But we can take 128 bit in parallel, you know, input wise. So if you've got a risk assessment or a KYC, task that's got 30, 40 different touch points that you're going to use to validate a transaction, or put the brakes on a buy or a close or whatever it is, then we can monitor, I would say at least 100 to 128 parallel touch points in near enough real time to give you signal monitor type system. So whether that's part of that input is linked to other systems, or your own and world events, I don't think it really matters. I think if we're going to work together, we need to understand the sort of things that you want to do. Where can you save money or speed things up, and then we can devise a way to access the technology, because it's not like a computer where you just say, oh yeah, I'll write a program and it's going to be great. We need to evaluate them.
Greg, let me just close from our side and say that we can do a lot of things together, but we just need to focus on what we can do on the low-hanging fruits. So whatever issues you have on the trading platform, we can help you on that, make it stronger, better, more secure, whatever. And as we're going into the cryptographic world or cryptocurrency world, it's basically we need to keep an eye on what it is that we're doing. So we have tools that can help you enhance that. Have tools that can help you speed up the ways that you do things, and that's what our interest is in your project, is basically proving. But again, you have to keep in mind that our IBM API is only, Scott, is it 2 weeks old or 4 weeks old or 2 months? You've been working on it.
It's been up a few weeks now.
It's been live for a few weeks.
Yeah.
So you're looking into basically everybody that's on the call, you're looking into the future, and
and it's really fascinating.
It's very exciting.
Scott and Per, everybody have just saying thank you very much, very, very much. They like the presentation, the under impression of what's just happened, and they're looking forward to see you guys with us next time if we have something interesting to show. So thank you very much, and have a wonderful day today.
No problem.
You guys too.
Take care.
Cheers, guys. See you soon.
Ciao.
Bye-bye.
See you soon.
Bye-bye.